Hello, my amazing Algebra 3 students. We are ready for another exciting online trip. Today, we will find coterminal angles. Coterminal angles have the same initial side and the same terminal side. Let's look at an example. Here, we have 30 degrees. We start on the positive x-axis. The positive x-axis is our initial side as it is in standard position. So we go counterclockwise and the angle is positive. So here's the terminal side terminating in quadrant 1. See, initial side, terminal side. Now, let's look at another example. We started out with our 30 degrees. Let's start here on the positive x-axis, the initial side. And we're going to go counterclockwise. We go one complete rotation plus 30 degrees more. You see, 360 degrees is one complete rotation plus 30 degrees gives us 390 degrees. And see, both angles have the same initial side, which is what the positive x-axis, and the same terminal side in quadrant 1. So 30 degrees and 390 degrees are coterminal angles. They have the same initial side, the positive x-axis, and the same terminal side, which is in quadrant 1. Let's look at that 30 degrees again. Here's a 30-degree angle. The initial side is the positive x-axis. This time, we're going to go clockwise, which means the angle is going to be negative. See, we're going clockwise, the angle is negative. Well, we take that 30 degrees and we add a negative 360 degrees, we get a negative 330 degrees. So this is telling us that 30 degrees and a negative 330 degrees are coterminal angles because they have the same initial side and the same terminal side. There is a formula for finding coterminal angles. It says f of n is equal to theta plus 360 degrees times n. Now, theta is given. Theta will always be given. The n is an integer. Integers, no fractions, no decimals. So notice that the set of integers is infinite, so we can have an infinite set of, an infinite number of coterminal angles. Let's look at that formula. If theta is 30 degrees and we let n be 1, then 30 plus 360 times 1, 30 plus 360 degrees gives us 390 degrees. Let's let n be a negative 1. Then 30 plus 360 degrees times a negative 1 gives us 30 degrees minus 360 degrees, which gives us a negative 330 degrees. So we've used the formula to find coterminal angles. So that says that 30 degrees, 390 degrees, and a negative 330 degrees are coterminal angles because they have the same initial side, which is the positive x-axis, and the same terminal side. Remember that when the initial side is a positive x-axis, the angles are in standard position. Now, the angle does not have to be in degrees. The angle can be in radians. So here, I have an angle, theta equals pi over 4. The initial side is a positive x-axis. The terminal side terminates in quadrant 1. And you see I'm going counterclockwise, so the angle is positive. I'm going to use that same theta that is pi over 4. I'm going to start on the positive x-axis. Then I'm going to go counterclockwise, counterclockwise, counterclockwise. I've gone one complete rotation plus pi over 4 more radians. So it's pi over 4 plus 2 pi radians. Remember, 2 pi radians is the same thing as 260 degrees. So pi over 4 plus 8 pi over 4, because you know 4 going to 8, 2 times? So 8 pi over 4 is the same thing as 2 pi. You have to have like denominators to add the fractions. So it's 1 pi plus 8 pi will give us 9 pi over 4. Therefore, we can say that pi over 4 and 9 pi over 4 are coterminal angles. Why? Because they have the same initial side, which is a positive x-axis, and the same terminal side, which terminates in quadrant 1. Let's look at that again. Here is our theta, which is pi over 4 in quadrant 1, initial side, positive x-axis, the terminal side. This time I'm going to start on the initial side, which is the positive x-axis, but this time I am going clockwise which means that the angle is going to be negative, but you're still going to end up at the same terminal side. So this time I'm going to take the pi over 4 and I'm going to add a negative 2 pi. And a negative 2 pi is the same thing as a negative 8 pi over 4. When I add the 1 pi plus the negative 8 pi, I get the negative 7 pi over 4. Therefore, pi over 4 and negative 7 pi over 4 are coterminal angles. And again, why? They have the same initial side, the positive x-axis, and the same terminal side. I was just going in what? Different directions. This was going what? Clockwise. This was going, this one's going what? Counterclockwise. And this one is going what? Clockwise. So when we get through, we have that pi over 4 and 9 pi over 4 and negative 7 pi over 4. They're all coterminal angles because they have the same initial side, which is the positive x-axis, and the same terminal side. There's another formula that we can use for coterminal angles. When the theta is in radians, instead of saying theta plus 360 degrees times n, it'll be plus 2 pi. Remember, 2 pi radians is the same thing as 360 degrees. So we have here where theta is given, the n is still an integer. And again, 2 pi radians is the same thing as 360 degrees. So let's look at that formula using radians here. We're going to let theta be pi over 4. The n is 1. So it's f of 1. Pi over 4 plus 2 pi times 1. 2 pi times 1 is 2 pi. 2 pi is the same thing as 8 pi over 4 plus the 1 pi over 4. 1 pi plus 8 pi gives us 9 pi over 4. So that's how we got another coterminal angle. Then let's use that formula again. We have our theta being pi over 4. This time our n is what, a negative 1. So it's going to be pi over 4 plus 2 times a negative 1. This gives us a negative 2 pi. Negative 2 pi is the same thing as negative 8 pi over 4. We add to that the 1 pi, and we get a negative 7 pi over 4. So again, what we have here, we have that the pi over 4, let me show you again. We have the pi over 4, the 9 pi over 4, and the negative 7 pi over 4. They are coterminal angles. And remember also that as you review this video, remember to stop, rewind, review, stop, rewind, review. My love goes out to you.